Today we'll be using OpenAI GPT-4o for this demo. Let's take a look at the system specs we're working with. Today it's an IBM Power System with 64 threads and 2 terabytes of memory. When we go to the schemas page, we see we have the ability to pull from an IBM I on the exact same rack as our IBM Power running RHEL Linux. We're now going to go into our query history and find our query that will pull our anti-money laundering dataset from the IBM I to the RHEL Linux machine. By sending just the metadata to OpenAI, we're able to generate our schema from scratch. Let's see what it comes back with. When our schema returns, we have the ability to approve it before loading any data in. We have one edge as a transaction and one node type as an account. It's not an account sending a transaction back to itself, but rather an account sending a transaction to another account. Since we like the way this schema looks, we're going to go ahead and load our data in by selecting Create Graph. For this data set, we only want to look at the transactions. So we're going to go ahead and erase the account frame from the data set by pressing Remove. Now we finally get to finish loading our data into our schema by pressing the Upload button. And just like that, our 1 million rows of data have been loaded into our schema. Let's go ahead and examine a little deeper by clicking on Datasets. As you can see, we have 1.1 million accounts and 1 million transactions. Let's go ahead and explore it. This is going to bring us to our entirely no-code data explorer. By translating any language into Cypher on the fly, we allow for anybody to play the role of a data scientist. Let's go take a look at our bookmarks over here. And now we're going to scroll down and find one of our saved prompts we have for our payment graph. Look at this one that says, show me all the patterns that look like they could be money laundering. When we run this, we're sending the schema, the metadata, and the query prompt itself over to OpenAI. Let's see what we get back as our Cypher response. When it returns, we're immediately greeted with our Cypher query, as well as an explanation of what the query does, and some insight if you want to understand a little bit more about the problem. And now let's run the query. So it completed already. This one took 0.027 seconds and returned a result of just under 150 rows. As you can see, we're now greeted with our results in a table format. It's pretty hard to tell what's going on from this, although you do have the ability to download this at any time. But it gets a little bit easier to understand when we click on our graph visualization option. Not only do we have this A to B to C pattern we were originally searching for, but as you can see, there are some more interesting patterns that are formed as well. Take this one, for instance. This is a 1, 2, 3, 4, 5, 6, 7 hop, of which the payment is the exact same every single time and the nodes are all unique. Needless to say, this is not normal payment behavior. If you are someone who's looking for money laundering, that might be a good place to start. And here we get to see some of the more interesting patterns take form. Keep in mind, these are payments that are all the exact same amount being sent around in this way. So they're sending these funds around in a circle, and it turns out, every so often, kicking some off on the side. Thank you for taking some time out of your day to learn about our solution. Keep in mind, this is just one of the many solutions that Rocketgraph offers. Please visit us at rocketgraph.com to see more.